Hello everyone, my name is Mihai and welcome back to Full On DIY. If you've been waiting for as long as I have been waiting to install the Bridgeport head on my Harrison mill, well, the wait is over because in today's video I will be installing the ram and the Bridgeport head onto my mill. This step has been long overdue now, but it's the right time after a lot of work and effort that has been put into this to fit everything onto the machine. Without any further ado, let's just crack on with installing it. Oi, oi, oi. This is so bloody heavy. I should probably really invest in a straight edge. Just to go a little bit in. And it's nice and flushed with the machine body. Man, this is heavy. Don't know how much you can see here, but please excuse the angle. Much more comfortable and easier going. And with a bit of luck, I can also put the dowel pins. Oh, it's in. Yes, yes, yes. One more. Wiggle, wiggle. Yes, yes. Probably I should have bought some slightly longer ones. But what I might do after I lock everything in place and it's nice and square, I might just put a little bit of Loctite or the very weak True-Lock 395 that I have. I will only partially tighten them in the final tightening once I have the head on, and I'll do any required tramming. When everything was going maybe a bit too smoothly, I realized that I've done a huge screw up on this, and I'm not talking about bolts, literally a massive screw up on how I measured where the holes in the machine body are relative to the true dead center of the machine. When I put all this together and I wanted to insert these two bolts, I realized they were not going in whatsoever. After looking at the drawings and all the measurements that I've done, nothing seemed to be wrong, other than the fact that I had no reference on center to center distance of these two holes in relation to the true dead center of the machine. And this is very important because this is where I cocked it up massively. So long story short, overall, this whole thing, front part, ended up almost a degree pissed this way because I had to be able to shove this in, and it's already too late to be able to do any changes now. So in order to achieve that, I just removed the bottom dowel pin that squares this up to the rear end of the ram, twisted it a little, the holes then lined up, and it's sorted. But the risk of the head pivoting like this, it's there because I don't have that bottom dowel pin anymore, and it doesn't go in because it's ever so slightly shifted. The easiest and the quickest option would be to just rerun the reamer because it's very, very slight interference. Rerun the reamer and insert the pin, and that should be it. In the event of this getting loose, that still leaves me with a little bit of pivoting angle. So in order to make sure that's never going to happen, what I'll do, I will drill in rim for 10 mil dowel pin instead, just to do this properly. I've spent too much time on it to just fully mess it up at this very stage. I'll do that off camera. I am literally gutted because it happened, but hey ho, every day is a school day, and probably next time I'll think twice before I measure something. Let's go back to it. This head swivel gear I got with the knuckle, all of it for 30 pounds, like I said in the previous video. Not a bad buy at all. All the way in. Now I'll just have to pack it up with like a lot of grease. I've done the same on uh, the worm gear that's on the head. An old pair of pajamas. I don't wear dinosaur pajamas. These are from one of the kids, which I've been given by my partner for cleaning rags. Ugh. I'm not sure how much you can see now because I'm literally all the way in the frame. This is not going to work. Ugh. Nope. Are they in at the bottom? I'm not gonna lie, it was really difficult to insert the head onto them bolts because they kept going all over the place, and I kept pointing almost with my nose where they have to go so that she would move them in position. This is not the sort of thing I could have done without any sort of help. It was really, really challenging, and then he didn't want it to go over the swivel gear, and I kept pressing with my chest against the head, and my microphone kept crippling and muting and all that. An absolute, absolute nightmare. Whew. Oh, that was hard. That was absolutely flipping hard. Why everything has to be so bloody heavy? Ah, ah. This is the adapter that I kept bragging about, that I designed to attach this to the belt housing on the Bridgeport head. It's just a 6 millimeters thick steel plate that I got laser cut at DMS Laser Profiles. It's just following the bolt mounting pattern of the B35 flange and the two holes that are matching with the belt housing. I am going to secure um, the custom made dog pointed set screws with a little bit of thread sealant on the keyway. Yes, this is the good old trusty TrueLock 395. Is very weak. Before I move on, I have received mail from one of my subscribers. Um Thank you, George, for kindly sending this. I will attach his channel in the description down below. It's George Donaldson's workshop. He is in the middle of refurbing the Bridgeport Head himself. He does a lot of interesting machine refurb and some electronics as well. So please go check out his channel. This has been sent to me free of charge, and it is the flange for the back gear pulley that I was missing. He kindly got in touch on the comment section of the video where I was putting the belt housing together and offered to send me this missing flange, which I was going to either find a used one, but I couldn't, or get one laser cut. And to be fair, I was in the process of getting one made, but this was very much appreciated and it looks really, really good. I mean, mine did not even have this thief pattern here. Mine was like completely shaved. So I'm glad that I put it on the bottom, my original one, and not on the top, because the belts seem to lift whilst you disengage high gear, and this one is looking much better and is gonna get propped against this a lot better than it would have on the one that I had. So thank you very much, George. Again, much appreciated. Next, we'll just shove this on top of the belt housing. Oh, just go in, you. One more thing done and dusted. Oh, this is so uncomfortable. Mm. Ay. And it is now in place. And let's see how much clearance we have until I'm reaching the ceiling, and that is 87 millimeters. Plenty enough for airflow. Uh, I could have gone a little higher, but uh, it should be good enough as it is. Huge problemo over here. The head of the M12 bolts are barely clearing the cutout in the casting, but the bloody washers are well in the way, which limits me from being able to swivel this um, front and back. So I guess this needs to come out so that I can take the washers out and reinstall it and see if it then swivels. Well, it's much better now that I removed the washers. It still doesn't give me the full range of motion that the original motor probably had, but it's is the best that I can get unless I machine the heads of the bolts ever so slightly, or unless I change to M10, or unless I countersunk the holes for M12 countersunk bolts, but that's just going to be a bit of a ball ache. But at the moment, this is fully untensioned and this is fully tensioned, which I think is plenty enough to tension the belt. So I shall put the belt on and see how it's tensioning. After the cock up with the washers on the inside, now it does pivot very nicely. I managed to fit the belt. There is plenty of travel to slacken the motor to be able to install the belt on any of these positions, and there is also plenty of space to tighten the belt. At the moment, the belt is at its fully tightened position, and this bolt is right in the middle of the elongated hole. I was a tiny bit afraid that the edge of the pulley will be too close to the back gear pulley flange that I got from George. It seems to be like a millimeter in there. I'm not sure if that's supposed the 1 mil gap should be there, should be more. Maybe people with Bridgeport can let me know in the comment section how it's on their machine. But when I was starting to believe that I'm out of the woods, I'm actually right at the entry point. Um, I was concerned about this gap here. I looked over on Google, zoomed in on some photos. There is a mixture of everything, really. Some users have this way up because they only use certain stages of the pulley. On some, you can't really see much. So I decided to give George a shout over WhatsApp, and he got back to me saying that on his machine, this gap is around 3 millimeters, and my setup is very close. So I measured the gap on this is 1.3 mil. Um, and then it got me uh, started to think what have I done wrong, because in theory I haven't missed any parts or I haven't added anything extra other than the non-standard motor with the hub that I have machined from scratch. And then I had a moment of reflection and it came to me immediately. When I've done the vertical alignment for the pulley, I have not even considered that the spindle pulley stack moves up and down. So when I've done the measurement, the pulley was in high gear, which means all the way down. The moment this lifts all the way up, the belt will end up at an angle. So what I should have done is to figure out the overall travel of this, and half of that should be the center point of the belt. So, for example, if this goes up and down 5 millimeters, this should have this clearance that it has at the moment plus 2.5 millimeters, half of the travel of this, so that it ends up as at a slight angle when it's in high gear and low gear, but never dead through parallel to this pulley as a reference point. So I guess this is coming back out again, and I'll have to find a place where I can shave 2.5 millimeters from, or approximately. I need to figure out the overall travel of this first. I'm kinda back to almost square one. Okay, let's see how far this moves now. A mil, 2 mil, 3.05 millimeters. After spending 10 minutes on the lathe, I have modified the hub to allow this to sit higher. The easiest way would have been to machine from this face of the hub, but because this hole is drilled and tapped through the aluminum pulley in the steel bushing, the hole would have ended up higher or lower, and that would have deemed that unusable, and I couldn't have put the set screw through anymore. So luckily I have left plenty of material up the bore, and I literally just removed 1.5 millimeters from the overall initial depth, so that this now can sit a lot higher. Back in position now. The gap, it's big enough. It's literally 3 millimeters there, or like 2.85, and it seems to have the right clearance, and the belt sits at an ever so slight angle. And then when back gear is engaged, that angle move upwards. When it's disengaged, the whole thing move downwards. Finally, after numerous up, down, take it off, put it back on, take it off, put it back on, it's all sorted. I can now finally get to tram the head, and this is probably the last time when I will have to do so much knee cranking. Whew. This contraption here is the only tool that I have available to tram the head. At this moment, I don't have anything that can go up the spindle. I'll probably make something in the near future. In theory, the outside of this, it's precision ground, so it shouldn't make any difference. Okay, that's now touching and it's on 0. And I will spin it to the other side. You're not going to be able to see. I will try and not touch the spindle here by any means, and I will just do it from the side access in the belt housing from the pulley directly. On this side we have 0.15 difference, so it's higher by 0.15 of a millimeter. Point 0.025 here, so lift it ever so slightly from this end. Now it's on 0. I will get the head holding nuts a little tight now because I don't want any movement, because I'm literally uh, almost dead 0. 0.02 on this side. Point 015, 0.02 on this side. Okay, it's trammed on X. Now I need to tram it on the Y from the contraption mechanism that I built into the head to do uh, Y-axis tramming. Okay, let's see what we get straight off the bat without any adjustment to actually more or less check how flat or how parallel are the parts that I machined on the ram. I will gently have to lift the knee until we get the reading. I'll bring it to 0.05. Nothing. So the head, it's leaning forward. So I have to adjust the two lower set screws so that this entire thing shifts this way. 0.01. Yes. 0.01. Bang on. That's it. Having tilted the head this way, so spindle nose went upward slightly by 0.11 of a millimeter, that means in theory I should have a 0.11 of a millimeter gap between the back of this plate and the machine body. Now I do not have a dead-on 0.11 of a millimeter filler gauge, but I'll try with 0.15 and it's not going in. And then with the 0.13, it does go in with some effort. Now I will have to shim this part, because the moment I'm tightening these bolts, it will either pivot the head back into out of tram position, but I do not want to put unnecessary bend forces on this. So I need to look up to see if I have anything that I can use for this side and the opposite side. I do have something. It's a very thin piece of brass, I think. I have multiple of this. I don't have anything else other than this. And let's see what this one is miking at. So 0.125 of a millimeter. That's one in. This is all I had in store for today's video, and it is the Friday before my Sunday upload, and it is 8:37 in the evening, and I realized that I have not ordered the cable to connect the motor to the electrical box. Time just literally ran away from me. Before I started to put all of this together, I thought that it will be smoother sailing than what's actually been, but that was not the case. It hasn't been without challenges or without mistakes here and there. What matters is the end product, which is exactly like I hoped for. There are still few bits and bobs that I have to do. Maybe you observe that I have machined only these two nuts, the very end of them, to like a round profile, because I intend to design and 3D print a bracket because I want to have a scale on the quill. It will be a basic uh, vernier style scale because my DRO has only a 3-axis input and I cannot put an extra scale to it. Hence the reason for a vernier style one. If you like what I'm doing, please like and subscribe. Also, huge thanks to everybody that has offered really good advice on the shaper video. Thank you all for watching, and I will see you in the next one.